Okay, this is the demo for the construction of this more conventional, though not an entirely conventional, turn signal actuator for the second generation WIKISPEED dashboard. Uh, these are the little joysticks that this is based on, and as is the thumb control for the steering wheel. These are marvelous little. I'm very impressed by the construction of these. They're about $2.50 each in quantity one. They're made in France, and they're from C&K Components, and I bought them through DigiKey. I'm really impressed by the quality of these. They are really well built, and the tactile feel of them is very good. I've tried some other switches as well that had adequate functionality from a standpoint of that they had the right connectors and so on and so forth, but they're all junk compared to these. These are really good. The problem with these is that they're so small. They're really designed for being integrated into things like Bluetooth headsets and that sort of thing. So they're very small and difficult to deal with in that respect, but quite robust. They're rated at I think 300,000 control movements in each direction, which is as this sort of thing goes is pretty good, particularly for $2.50. I needed to mount them on something, and they're made for surface mount, and so went to my local Radio Shack, and the only thing that I could find that would come anywhere near fitting the bill was this thing made by Smartboard, and I used the top portion of it and it's a little surface mount. It's made for a surface mount IC. This didn't line up perfectly on it, but it was close enough, and I did some really ugly soldering and got it to work, and put some headers through it, similar to this, though a little shorter, and then I mounted it on. You can see that there's a bit of this rather generic prototyping circuit board missing from this one. That is in fact what it is mounted on, and there it is in there, screwed through with the I bought a couple of hinges at the hardware store, and that came with screws, and you can notice there's two of them missing. That's where they are. I'm a software engineer by trade, and I'm not used to putting together hardware, and if I looked at a piece of software that was built like this, I would say that it was an incredible hack, and I make very few excuses for this. I did what I could with what I could get my hands on, and I apologize. On the back side, so on the other side of this that you can't see is one of these mounted to one of these, and then on this side, which you can barely see, there are a bunch of resistors, and they go in increasing values from 10K up to 100K, that each progressive switch closure adds to it, and all with reference to ground. One of these connectors goes to ground, the other one goes into the analog 0 input of the Arduino. So as you put the switch in any which direction, it's going to get the reference to ground through those however many resistors are in series at that point. The schematic for this is going to be, I'll be uploading that with actually not with this video, but shortly thereafter, and I'll also be uploading at the same time that I upload the schematic. I'll be uploading a fritzing diagram of all of this stuff. So, or I should say, multiple fritzing diagrams of all of the various pieces. Okay, so that's what it looks like. As far as the physical construction of this is 3 inch, no, I forget, 2.5 or 3 inch, with 3/4 inch T, just standard plumbing PVC that I got at, I think it was either Lowe's or Home Depot. What I did was I first made this cut, and I used a saber saw that I bought in just a handheld saber saw that I bought back in 2000, and I used its original blade. I don't do a whole lot of this kind of stuff. I made that cut, then mounted these hinges, which I bought at the same place, and then made the cut on the other side, and the closure here is a piece of Scotch tape. And this is just telephone hookup wire that comes through a hole and goes into an RJ. I guess this is it's not 11. It's a RJ12 connector. Though just because I couldn't find an RJ11. All we need is 2 wires out of here, so that's plenty. So the other thing, okay, so now the thing is that the way that this actuates the switch, the joy switch, let me just take one of these out so you can get a better look at it. Okay. I don't know how well this is going to come out, and I'll upload the PDF of the but there's this little tiny actuator here that actually a little button is supposed to go on top of. But what happens is this chopstick here. It's a bamboo chopstick. I drilled a little hole in the end of it that sits on here, and there's a little washer in the middle here that acts as a fulcrum, so that we're actually, as you push down, it's going against the fulcrum and kicking it in the opposite direction. And I'll just show you how that's constructed here. So there's the end of it. Now you'll notice that there's a little silvery thing there on it. That's because I found that I needed to reinforce this for the bamboo because it was splitting. And what that is I went to a model store and bought some. I actually had this already. This is some little square aluminum stock, and I just forced a piece of that onto the end of the chopstick here, and then crimped it with a pair of pliers so that it would reinforce the end here. Because just having a little drill hole in there wasn't enough. I really really think I need to find a better way to do this. Really is not the way to go about doing this. So we have here just a 3/4 inch union, PVC union. This is a 3/4 inch T that I bought. And then inside here, this is just a piece of 3/4 inch PVC pipe, plain and simple. I just nothing special there. The union is one with a ridge inside, and I don't know how well you can see that, but I just wrapped a piece of copper wire that's actually telephone hookup wire, solid telephone hookup wire. That's just to stop it from pulling out. There's a better look at the reinforced end of the chopstick. This washer here I made by using a hole saw to cut out a piece of plastic from some plastic that I had laying around, just a sheet of plastic. I think it's probably 1/8 inch plastic, and the hole saw, it wasn't the right diameter. It was too large, so I just stuck a nut and bolt through here and spun it on a drill motor and hit it and ran it against a file until it was the right diameter. So now it fits in there nicely and creates that fulcrum that actuates the switch, and you can actually get a look at the switch that's sitting down in there. Where was that? There we are. So that's one of these sitting down in that hole, sitting on one of these, sitting on a piece of this, screwed onto the PVC. I'm sure we can do a whole lot better than that. Oh, and this RJ11 connector, I was going to JB weld it here, but then I thought, it's got this nice little detent there that's made for going into a little socket, and it just sat so nicely there, and I just used a piece of telephone hookup wire to secure it to the side there. So it's not there. It's there well enough. It'll work. It'll hold. Putting this all together is a slightly delicate piece of work, because you've got to get this thing perfectly lined up onto the joystick, and you've got to make sure that it's got the right depth so that it can actuate the downward motion on the little switch, and be able to get it in all the directions, so you just center it as best you can and start going down until you feel it engage. Oh, of course, during the demo, it's always the toughest. But we'll get the job done. There it is. Okay, so I'm on it now, and I'm just going to tighten it up until we've got the right. Yeah, we've got it. It's all working now, and there we have it. I hope I haven't forgotten anything.